Okay, so now let's start our next test, second test sessions. And here we'll talk about the independency test, dependency test, ANOVA, actually the mean comparison. Now, before going to the mean comparison, just me give you the idea. Basically, the mean comparison or independency tests or dependency tests are called inferential statistics. Inferential statistics. So yesterday we talked about descriptive statistics. And basic.
Excuse me, sir. Kindly please record recording पे लगा दें.
जी लगा दिया आप, don't worry. Descriptive statistics, and the other thing is inferential statistics. There are two types of statistics. Now, descriptive statistics is used to define or describe data. Okay. On the other hand, inferential statistics is used to generalize results or test hypothesis. So whenever you have a hypothesis, in your study, then you must use inferential statistics. Now, what does it mean by hypothesis? Hypothesis is actually a tentative statement which tests based on some statistical test. Hypothesis is used to generalize results. Now, what does it mean by generalizability? Generalizability means when you conduct any research and you want to conclude this result for the whole population, then you need to make hypotheses, and then you need to test those hypotheses. For example, let's say job satisfaction. Now, do you know what is job satisfaction? Which means how much someone is satisfied with his or her job. For example, if you want to study that is there any difference in the job satisfaction between married women and unmarried, or let me write married female and unmarried female. Okay, so for example, you want to test that, or you want to conduct a study, is there any significant difference between job satisfaction between married women or unmarried women? Or for example, your study to see the significant difference in the job satisfaction between male teachers and female teachers. If you have a study, such kind of study where you want to compare two groups. Now, two groups means here male is one group, female is another group. And if you want to test something like job satisfaction, stress, anxiety, opinion, or anything, any psychological state. Now, see, this job satisfaction is a one variable. I'm putting red color, and then male and female teachers are like male and female are two groups. So how many variables involved in this study? There are only two variables. Which one? I'm sure that if you are aware of the type of variable, then you know one is job satisfaction and the other one is gender. Now, gender has further two groups are level. One is called male and other was called female. Always remember that male and female is not variable. You cannot say male and female are variable. Male and female are categories, are values. Gender is a variable. So gender is a first variable, job satisfaction is another variable. So for example, if you want to see a significant difference in job satisfaction between male and female teacher, so how would you make null hypothesis? Your null hypothesis would be there is no significant difference in job satisfaction between male teachers and female teachers. So this is null hypothesis, and this is null hypothesis. Now, how will you test this null hypothesis? You can only test this hypothesis by using inferential statistics. Now, there are so many tools of inferential statistics. One of them is independent test, dependent test, or ANOVA, which we'll discuss today. Now, independent test is used if you want to see a significant difference between two groups. So if you are in your study, there are two groups like male and female, public and private, rural and urban, one province and other province, morning, evening. If you have this kind of study, then you will use independent t-test. Okay, so as I'm telling you that morning, evening, these are the two values or two groups. The session can be one variable. So in independent, we use independent t-test when we have a two group and we want to test one thing. So like for example, this case, see this case, there is no significant difference in job satisfaction between male and teachers and female teachers. Now there are only two variables, job satisfaction and male and female teachers. Male and female teachers variable is gender and job satisfaction is another variable. So male and female teachers are categorical variable or nominal variable because there are two categories, and job satisfaction are ratio type or other type of variable. So this is the basic idea about null hypothesis or significant test, and I'll also explain furthermore. But actually, before moving to running the independent t-test, I thought that I should recall you what actually independent t-test is and why we use independent t-test. Okay, so in independent t-test, as I told you that there are only two variables. One variable is that ratio type variable, which is job satisfaction, or can be anxiety, it can be opinion, it can be a test score, it can be a quiz score, it can be a science proficiency, even it can be a job performance, even it can be a teacher performance, student performance. Anything that you measure through a number and you want to compare between two groups, then you will use independent t-test. So let me see that, let's say again, just start from the scratch as we did yesterday. So there are two variables, job satisfaction and gender. So for example, job satisfaction, as I told you, it is actually a construct. If you remember, what does it mean by construct? Anything that cannot be measured directly. So you cannot measure someone's job satisfaction directly. There is no inchy tape, there is no tool, there is no instrument in the world that can measure job satisfaction. There are the instruments that can measure blood pressure, there are instruments that can measure your weight, there are instruments that can measure your height. So the height, weight, blood pressure level, sugar level, these can be directly measurable. Even the length of the room, height and weight, even the distance can be measured directly. But the psychological traits like anxiety, job satisfaction, opinion, attitude, behavior, that cannot be measured directly. So that's why it's called construct. So since we cannot measure directly, so we measure it by set of items. So we cannot measure construct directly, therefore we measure by set of items. So set of items, we need to develop a set of items. Maybe there are certain, there are also so many instruments available related to job satisfaction. So I'm not going into detail how you can develop your questionnaire, but whichever questionnaire you use, you can actually use that questionnaire to measure a significant difference between two groups. So if you remember the data which I gave you and day one data, which is I also uploaded on SPSS. So this is the data, and I requested you to fill the sheet, worksheet. So this data has a gender, Gender has two values, male and female. And qualification has B.Ed, M.Ed, others. Occupation, job status, experience, teaching level, province, and these are the 12 items. These 12 items actually related to teacher sense of efficacy. So these are the items. So I'm just using this data. So these are the 12 items, and 12 items is related to teacher sense of efficacy. Teacher sense of efficacy means how much teacher is confident to teach disruptive students or unmotivated students. So for example, this is the data you collected. So what would be the null hypothesis in this case? Null hypothesis, there is no significant difference in teacher sense of efficacy between male and female teachers. Okay, so this is the null hypothesis. Best I just developed it. So there is no significant difference in teacher sense of efficacy between male and female teacher. Again, when you have a questionnaire or instrument, questionnaire is actually used to collect a data or thing that cannot be measured directly. So as I told you in just a few minutes ago, that job satisfaction cannot be measured directly, anxiety cannot be measured directly. Similarly, these things, teacher sense of efficacy can also be not measured directly. So that's why I make this 12 items. These 12 items actually is related to teacher sense of efficacy. So I hope that you are getting my point, that what I want to convey you, that when you collect a data through questionnaire, there are so many items, so many questions, but that item actually does not tell you anything. So this one item, two item, three item does not tell you anything. You can check the descriptive statistics, you can check the inferential statistics of item 1, item 2, item 3, but it does not make sense to compare male and female between for Q1, because Q1 itself is nothing. Q2, Q3, Q4 itself is nothing. Actually, the composite of Q1 to Q12 make something, which is teacher sense of efficacy. So similarly, if you have job satisfaction scale, one item does not make any sense. So you have a set of items that measure job satisfaction. So that set of item composition or average is actually a job satisfaction. So similarly, since I make this hypothesis for you, that I want to test that there is no significant difference in teacher sense of efficacy between male and female teacher. Now, what type of analysis should be used? Now, this is very important. And actually, I explained you, so I hope that you know the answer. But it is very important to understand that what is the logic behind it. Because so many times, students ask me, scholar ask me that this is my hypothesis, this is my data, please tell me what kind of analysis I should use. So that's why it is important for you to understand what kind of analysis should be used in which kind of situation. So right now I'm telling you about independent t-test. Independent t-test is used to compare the mean value of between two groups. So whenever you want to test a difference, check a difference, or test a significant difference between two groups of anything, any construct, job satisfaction, test anxiety, teacher sense of efficacy, attitude, behavior, science score, math score, whatever, you will use independent t-test. So if you read the null hypothesis, there is no significant difference in teacher sense of efficacy between male and female teachers. So what do you think? What should we use here? Independent t-test. Why? Because There is one thing which we want to test, which is teacher sense of efficacy, and there are two groups, which is male and female. So it can be morning, evening. It can be one province to another province. It can be Sindh in Punjab. It can be rural teacher, urban teacher. Regardless whichever two groups are, you can always use independency test. Okay. So how will you do in SPSS? Is very simple. So this is our data. So as I told you that this individual item is not making any sense. You can use descriptive statistics, frequency, mean value for individual item. But if you want to run inferential statistics, if you want to test any hypothesis, then you need a composition of this item. And I told you yesterday how you can make an aggregate of this item. Is simply take an average of this 12 items. The average of this 12 items will make a teacher sense of efficacy measurement. So how we can do it? We already did yesterday, but again you miss it. Don't worry, we'll repeat it. So compute variable. In compute variable, write the name of the target variable. So I'm writing that name of variable teacher efficacy. And I put the space, just let you know that it does not allow you. So if I put it will show the error. So in variable, there should be no space. So I'm just writing teacher efficacy without any space. And what would be the numerical expression? A numerical expression will be Q1 plus Q2 plus Q3 plus Q4 plus Q5 plus Q6, Q7, Q8, Q9, Q10, Q11, and Q12, and bracket close and divided by 12. Why we are dividing by 12? Because we have a 12-item questionnaire, and this teacher sense of efficacy measurement is measured by 12 items. So this 12 I add up and divide by 12. It is actually the formula of taking average. So the average will be calculated and moved to the teacher efficacy variable. And I simply press OK, and it is executed. If I go to the data view, in data view, you will notice that another variable is created with the name of teacher efficacy, and this 8.58 is actually the average of this 12 item. Now things are very simple now, clear now, straightforward. That now you want to test this teacher efficacy of every teacher. This is the teacher efficacy of every teacher, and you want to compare the teacher efficacy of between male and female teacher. You want to test it. So you will use independency test. What type of analysis you should? Independency test. And why? I already told you we use independency test because there are two groups between. We want to test this between two groups, which is male and female. So I hope you got it. Let me add other members. Okay, now how will you do it? Simply go to analysis. Fire. Okay, go to analysis. In analysis, there are three. Go to compare means. In compare means, there are 5 to 6 sub menus. So this is the means. This means means average. This options calculate the average group by group or average for all. This is one sample t-test. This is independent sample t-test. If you have two groups, an independent and you want to run independent t-test, then you will use this option. Summary independent t-test. In previous version, this option was not available, but in this version, this option is available. If you have a raw data like this number kind of data, then you don't need this summary independent t-test. So basically, this whole menu has three things: independent sample t-test, paired sample t-test, which is also known as dependent t-test, and the lastly, one-way ANOVA. So hopefully by the end of today's session, we'll cover all these three: independent t-test, paired, and ANOVA. And it takes a little more time to discuss and explain independent t-test because this is the first inferential statistics tool which I am explaining you. So that's why I'm just giving you some basic ideas, some explaining some basic terminologies as well. So we'll go to the compare me's and we'll go to the independent sample t-test. In independent sample t-test, this is the list of variable. Just simply right click and you can say display variable names, so it will show the variable names. So what variable you want to test? I told you Q1 is a variable. Every item is a variable, but every item does not make any sense because this 12 item composition of this 12 item is make teacher efficacy. And what is your hypothesis? What is your research purpose? Your research purpose is to see a significant difference in teacher efficacy between male and female teachers. So, which means your test variable is teacher efficacy. And how we get the teacher efficacy? By taking average of these all 12 items. Okay? And grouping variable. Grouping variable means a variable, a categorical variable, or nominal variable in which you want to compare teacher efficacy. So you can go to up and see there is a gender variable. So since you want to compare a teacher efficacy between male and female, then it is gender is the variable that hold male and female. So click here, and this is the gender. In gender, define group. So group 1, here you need to write the code value which you mentioned for the male and female. So if you remember, we mentioned for male 1 and for female 2. Now it is not it is not mandatory to write group 1 as 1, group 2 is 2. You can also write group 1, 2 and group 2, 1. But it is important that you should write the code as you mentioned in the gender level. So I'm just just explain you again that in a variable view, when you declare the variable, you mention the values. Here is the gender variable is a values. In the values, there are 2 values. One is male and 2 is female. So this is actually a 1 and 2 is a group code for male and female. So that's why in analysis, compare means independent sample t-test, and then put the teacher efficacy here, and grouping variable, the grouping variable will be gender, and defined group, group 1 code 1 and group 2 code 2, and continue, and then simply press OK. If you press OK, output will be generated, and this output is actually the independent t-test result or inferential statistics result. And independent t-test generate 2 tables. One is called descriptive statistics table, group statistic table, and other is called inferential statistics table or independent sample t-test table. So if you see the group statistic table, they are male and female. So just it give you idea that how many males are there, what is the average teacher efficacy of male, and what is the average teacher efficacy of female. And this is independent sample t-test table. Now independent sample t-test table has a very long table, and there are 2 rows. One is called equal variance assumed, other is called rows is called equal variance not assumed. Independent sample t-test has 3 assumptions. One is called normally distributed data. Data should be normally distributed. Second is homogeneity of variance. Homogeneity of variance means both groups should have equal variation, equal change. And the third is both groups should be independent. So the assumption of independent t-test that equal variance should be assumed. So you should always get the result from the first row. In the first row, this is the value significance 2.011. It is the value that help you to determine or to make a decision regarding whether you have to reject null hypothesis or fail to reject null hypothesis. In other words, this value will tell you whether there is a significant difference in teacher efficacy or there is no significant difference between teacher efficacy. So How will you make a decision? Simply, okay, let me add other members. So how will you make a decision? Simply, this is a simple rule. Compare this value with your set alpha. Alpha is a predetermined value. You might heard about the alpha value or level of significance value, which is usually 0.05. It is actually, if I explain it in the further, what is alpha, what is level of significance, then we may have a short of time to discuss ANOVA. So maybe in other short video, I will explain what is alpha, what is level of significance. Just in a briefly, I'm just explaining you that alpha is actually, alpha is a predetermined level that a researcher set. So alpha are level of significance is predefined set of level. It is actually a probability of making wrong conclusion. In statistics, in inferential statistics, there is no way you can make 100% accurate result. In statistics, there is always room for error. There is always probability of error. That probability of error is considered as alpha level. So in social sciences or in other sciences, usually the alpha is set to either 0.05 or 0.01. Now 0.05 means 5%. 0.01 means 1%. Now what does it 5%, 1% means? 5% means that you are willing to make a 5% chances of error in your result. In other words, your result would have a 95% accuracy, 95% authenticity, and 5% probability of error. So for example, when you conduct a research, your set alpha is 0.05. Please turn off the mic. Please turn off the mic. So if your set alpha is 0.05, and as I told you that usually this alpha is set by the researcher while writing the proposal or conducting the research. So this is already defined. Either you need to set 5%, 1%, or sometime 10%. 10% is too big number. Normally in common practice is that set alpha is 5%. 5% means 0.05. So you need to compare, make a decision about independent test hypothesis testing based on this 0.011 value. If this value is less than your set alpha, then you reject null hypothesis. If this value is more than your set alpha, then you fail to reject null hypothesis. So maybe you missed my point, so I will just write it so that you will always remember it. And this is the rule for every inferential statistics. Regardless what kind of test you are using, this is the rule for everything, every kind of analysis. So if this value, I'm just highlighting. So if SPSS significant value is less than set alpha, which is normally 0.05, so you would conclude reject null hypothesis. If the SPSS significant value is more than set alpha, then you fail to reject null hypothesis. So always remember this rule, because this rule is applied in all kind of statistical tests. Either it is ANOVA, dependency test, independent test, correlation, regression, structure question modeling, chi-square, whichever your test you are using, this rule is applied to all to make a decision about your hypothesis, whether you need to reject it or fail to reject it. So our set alpha is 0.011, and I make this condition that if SPSS significant value is less than our set alpha 0.05, when we reject it, otherwise we fail to reject it. So look at this, our SPSS output. This is our SPSS out. Please turn off the mic. Please turn off the mic. I request you to turn off the mic. This is our significance value 0.011. Okay. And what is your set alpha? 0.05. Now ask yourself, is this value is less than alpha or more than alpha? ये value जो है 0.05 से छोटी है या बड़ी है? If this value is less than 0.05, then you will say reject null hypothesis. If this value is more than 0.05, then you will say fail to reject null hypothesis. As I can see that this value 0.01 is less than 0.05. So our result would be, we would say reject null hypothesis. Reject null hypothesis. Why we reject? Because 0.11 is less than 0.05. So the SPSS significance value or probability value is less than our set alpha value. That's why we reject null hypothesis. Okay, so this is how you make a decision. Now it is not important to reject or fail to reject. You can learn this skill by any things, any video, any book. The important thing, what does this reject null hypothesis mean? So our result is reject, our decision is reject null hypothesis. Okay, so what was our null hypothesis? Our null hypothesis is there is no significant difference in teacher sense of efficacy between male and female teachers. And our decision is reject null hypothesis. So assume that you are rejecting this null hypothesis. When you are rejecting this null hypothesis based on the decision, then what will be your conclusion? There is a significant difference in the teacher sense of efficacy between male and female teachers. So you can say with confidence, with 95% confidence, that you can say that there is a significant difference in teacher sense of efficacy between male and female teachers, because the data is suggesting that you need to reject null hypothesis, and the hypothesis, null hypothesis say कि इनमें कोई फर्क नहीं होता. So if you reject this statement, the conclusion would be that there is a significant difference in teacher sense of efficacy between male and female teachers. Now this conclusion also provide a room for further research, provide a room for the direction for the future researcher, provide you the ideas for the recommendation. Let me explain us something in Urdu. So I'm just sorry for the foreigners if someone is here. That अगर आपका कोई conclusion इस तरह का आता है कि टीचर की सेंस ऑफ एफिकेसी मेल और फीमेल टीचर के दरमियान फर्क है, which means कि मेल की और फीमेल की टीचर एफिकेसी अलग अलग होती है, तो it give you idea, it give you मतलब ये दिमाग खोल लेने के लिए काफी है ये कंक्लूजन कि मेल और फीमेल यानी कि जो जेंडर है उसमें ऐसी क्या खास बात है जिसकी वजह से टीचर सेंस ऑफ एफिकेसी मुतासिर होती है, जिसकी वजह से टीचर सेंस ऑफ एफिकेसी में चेंज होता है. फॉर एग्जाम्पल, अगर टीचर सेंस ऑफ एफिकेसी मेल और फीमेल में कोई फर्क नहीं होता तो हम ये सेफली कह सकते थे कि भाई जेंडर कोई सा भी हो, टीचर सेंस ऑफ एफिकेसी का कोई ताल्लुक नहीं होता. लेकिन अभी जो हमारा कंक्लूजन आया है इससे हमें और एक आइडिया जनरेट हो रहे हैं, हमें एक ब्रेकिंग न्यूज मिल रही है, की इंफॉर्मेशन मिली है. की इंफॉर्मेशन इज दैट there is a significant difference in the teacher sense of efficacy between male and female teachers. Now this again, this information is not sufficient. there is a significant difference. We also need to know that which either male have a higher sense of efficacy or female have a higher sense of efficacy. So we can get this information from group statistics. If you see the group statistics, male mean is 7.8 and female mean is 7.39. So the mean value is higher for the male. In other words, you can say that male teachers have a significantly higher teacher sense of efficacy than female teachers. So आप देखें, there are three information we obtain on independent test. Number one, कि आया you reject or fail to reject null hypothesis. Second, कि कोई difference है या नहीं है male female में. And the third, कि जो difference तो चलो पता चल गया है. अब ये पता करना है कि मेल ज्यादा की टीचर सेंस ऑफ एफिकेसी ज्यादा है या फीमेल की, वो कैसे पता चलेगा? वो मीन से पता चलेगा. तो अगर इफ द रिजल्ट वुड से कि देयर इज नो सिग्निफिकेंट डिफरेंस, अगर रिजल्ट ये आता है कि देयर इज नो सिग्निफिकेंट डिफरेंस, देन इट डज नॉट मेक सेंस कि विच वन इज हायर, क्योंकि आपने कौन सा हायर है, विच वन इज ग्रेटर is the question to be answered only if you know there is a significant difference. So if there is no significant difference, there is no need to answer which one is higher. So I hope that you got the idea what is the basic use of inferential statistics, what situation we need to in what situation we can use independent test, and how we need to analyze data. And this is actually APA formatting of interpretations or result writing. Whenever you write any result, it is better to write one introductory sentence. Introductory sentence, you can say an independent test was used to see the significant difference in teacher sense of efficacy, between male and female teachers. Then you can say result indicated that there is a significant difference in teacher efficacy, teacher sense of efficacy between male and female teachers. The third line you can add up, moreover, result also shows that male teachers have significantly higher sense of efficacy than female teachers. So see, this is the one paragraph we can write and put in our result section based on this SPSS output. And as far as what kind of table you need to put in your study, in your thesis or in your article, it depends on your limitations. But if you want to copy this table, copy it, right click, copy it and paste here. When you paste it, since the independent teachers table is too long, you can right click it and then auto fit to window. It will show this table. And you can remove this Leven's test because it's not necessary to show here. And you can also remove this second column because you are not enhancing equal variance not assume. You are enhancing based on equal variance assume. And see, now this table looks better in terms of show, and it can also fit in one window in MS Word 1 document. So you can put this table, and then this is interpretation of the independent test. So you have this data. I'm giving you 5 minutes or 3 minutes. Kindly do some practice run this independent t-test and let me know if you have any question. You can put this question in the chat box. So I'm just giving a 2-minute break. In 2 minutes, just do a practice, or if you have any question, just write it, and then I'll come back again for dependent t-test and ANOVA.
Assalamualaikum, sir. Kindly share your Gmail address with us so that we can ask any type of question from you.
The email you are receiving, it's a Gmail address, trade@gmail. So you can ask any question. We sent so many emails, so it doesn't. I don't know which email you are asking. We sent so many email, and you can ask question through that email. So I hope that you got the idea of independent t-test, independent t-test. Now let's move to the dependent t-test or ANOVA. Dependent t-test is used to compare the significant difference between two groups. So for example, so dependent t-test are also called pair t-test, is mostly used before treatment, after treatment kind of study, or in experimental type study. Experiment type study. So for example, if you have collected data before treatment and after treatment, or before pre-test and post-test, then you need dependent t-test. Now, I'm not going into detail on dependent t-test because the procedure, result interpretations, and write-up for dependent t-test is exactly the same as independent t-test. How will you do analysis the dependent t-test? That's what I'm telling you right now. Go to analysis, go to compare means. In compare means, just like you run independent t-test, you can also run the paired sample t-test. When you click paired sample t-test, they ask the first variable and the second variable. First variable means before treatment variable, and second variable means after treatment variable. So if you are conducting an experiment and you measure something like anxiety, or for example anything, like even if you are from medical and you develop one medication or drug, and you are claiming that this drug can maintain the blood pressure level, so you recruit 20 to 30 sample healthy people and measure their blood pressure levels, and then you give them a drug or medicine, and after 15 minutes you measure their blood pressure again. So this variable 1 is considered before treatment, and this variable 2 is considered as after treatment. And then you, yes.
Hello, I can't listening.
Can you hear me?
Yes, your voice is clear, sir.
Okay, so I'm recording this video, so you can also, I will upload it and you can watch it. I'm just sharing that how you can run the dependent t-test. Dependent t-test, you have one variable before treatment, the other variable is after treatment. So put one variable here and put variable here, and then simply press OK. And then you can also make the same way, just like I told you about the independent t-test. You can also make a decision about dependent t-test result based on the set alpha value. So the dependent t-test will also generate the significance value, and you need to compare this significance value based on your set alpha. And if you have trouble understanding dependent t-test, I will also make a short video, but right now actually I'm just giving you one idea which situation you can use dependent t-test and how you need to analyze that. Because the only way you can understand it, or you can have a command on dependent t-test or independent t-test. Yeah, even if you want to have a command on SPSS the only magic is do a practice. You can never learn SPSS, you can never command on SPSS by conducting session. You can only, the sessions or webinars or even the tutorials only help you to put you in a track so that you can learn by yourself as well. That's why I gave you a data so that you can do a practice, and if you have any question, you are more than welcome to ask. In the last few minutes, I need to discuss about the ANOVA. ANOVA is called analysis of variance. Analysis of variance, we use ANOVA when we have two or more than two groups. So as I told you, we use independent t-test for two groups. But what if you have more than two groups? What, like here, for example, your study, one of your study purpose is to see a significant difference of teacher sense of efficacy between male and female. What if you have study, one of the purpose is to see a significant teacher sense of efficacy between teacher experience. Now experience have this group, less than 2 years, 3 to 5 years, 6 to 8 years, 9 to 12 years. See, there are 5 groups. And if you see the occupation has 3 groups: pre-service, in-service, teacher trainer. So if you have a such kind of situation when you have more than 2 groups, it is appropriate to use ANOVA. So ANOVA is used when you have more than 2 groups. So like either you use ANOVA, dependency test, independent test. These all are called mean comparison test. Mean comparison because it actually compare the mean value. If you have 2 groups, you will use independent test. If you have more than 2 groups, you will use ANOVA. So for example, again, if your null hypothesis is there is no significant difference in teachers' sense of efficacy based on their profession. So for example, this is the one of the your hypothesis that you are claiming, or you are saying, or you want to test that whether if teacher is in service or pre-service and you want to see a significant difference in, you have more than 2 groups, you will use ANOVA. या मिसाल के तौर पे आपको स्टडी करना चाहते हैं जॉब सेटिस्फेक्शन की या वर्क प्लेस हरासमेंट की स्टडी करना चाहते हैं, और वर्क प्लेस हरासमेंट में वर्किंग वुमेन, मैरिड वुमेन है, नॉन मैरिड वुमेन है, then you will use independent test. Same in study, if you have workplace harassment, one variable, and you want to compare based on the women who have less than 30 years or women who is between 30 to 40 years and women who is between 40 to 50 years. Now in this case there are 3 groups, so you will use ANOVA. So ANOVA is used when you have more than 2 groups. So is in this situation like occupation has 3 groups. So and you want to see a significant difference of teacher sense of efficacy based on the occupation, then you will use ANOVA or analysis of variance. Now how will you do analysis of variance? Go to analysis, compare means, and then click on one-way ANOVA. ANOVA, analysis of variance. In ANOVA, this asks a dependent list, and this is called factor. So display variable name. So what you want to test? You want to test a teacher efficacy, and what is the factor? Factor means a variable that has the 2 or more than 2 groups. So factor is occupation, because occupation is a 3 factor or 3 groups. One is in service, pre-service, and teacher trainer. So if whichever study you are conducting, if you are one group has more than 2, one variable has more than 2 groups, you can use ANOVA, and that will be considered as a factor. So I'll put the factor here. So teacher efficacy based on the occupation, and press OK. So again, ANOVA also generate one table, and this is ANOVA table. In ANOVA table, if you see this ANOVA table, again it provides this significance value, which is 1.141. So if you remember the rule is says that if this value is less than 0.05, we reject it, otherwise we fail to reject it. So it seems like this value is more than 0.05. 0.05 से बड़ी वैल्यू है, तो हम ये कह सकते हैं, we can conclude that fail to reject null hypothesis. So I'm just copying this table and putting this here just to show usko copy paste. If you want to put this table in your thesis article, you can always put this. So this is the significance value point is A. So you can, your conclusion would be fail to reject null hypothesis. Why fail to reject? Why? Because I'm just writing just for your own understanding or explanation. Because this significance value, because 0.141 is more than 0.05, जो हमारी अल्फा वैल्यू से बड़ी है. So we fail to reject null hypothesis. If we fail to reject null hypothesis, what would be our research conclusion? Our research conclusion would say that there is no significant difference in teacher sense of efficacy based on occupation. Okay, so in other words, अगर हमको मैं इसको सिंपल से लफ्जों में डिफाइन करूं, तो टीचर इन सर्विस हो, प्री सर्विस हो, टीचर ट्रेनर हो, इसका कोई ताल्लुक नहीं बनता या उससे कोई फर्क नहीं पड़ता उनकी टीचर की एफिकेसी पे. तो अब देखिए, दिस काइंड ऑफ इंफॉर्मेशन हाउ यूजफुल इट इज. यू कैन मेक योर रिसर्च रिकमेंडेशंस, डायरेक्शन फॉर फ्यूचर रिसर्च बेस्ड ऑन दिस कंक्लूजन. That's why I emphasize you to please understand it. क्योंकि अगर आपकी अंडरस्टैंडिंग डेवलप हो गई ना, then आपका माइंड जनरेट करेगा रिकमेंडेशन. So अगर हम if we concluded that teacher sense of efficacy has no difference based on the occupation, then we can safely say that if teacher is in service or pre-service or teacher trainer, it doesn't affect their in teacher efficacy. So this is how you can conclude ANOVA result.